All right. So on the same topic of dams and dam failure, we're going to move to Nathan Schaepe with U.S. Geological Survey, investigating the impacts of 2019 Niobrara River dam failure to riparian habitats of the upper 39-mile segment of the Missouri National Recreational River. So with that, Nathan, I will turn it over to you.
As John mentioned, I'm going to be talking about the Spencer Dam failure as in reference to the Niobrara flood of 2019 and looking at how that impacted habitats on the Missouri National Recreational River. So as many of us in the upper Midwest experienced, we had historic flooding in 2019. And northern Nebraska was no exception. We had a combination of wet fall and summer, wet fall and winter, sorry, and exceptionally cold, and then exceptionally cold late in the winter. And then on top of this, we had a bomb cyclone precip event in March. It fell on this frozen ground, and so we had a large amount of runoff. It triggered a lot of ice melt on the river and on the plains, and so this created a large amount of water rising in a short amount of time, and which included a lot of ice, especially on the Niobrara River. And what happened was all this ice and all this additional water caused the dam on the Niobrara, called Spencer Dam, to fail. If you can see my arrow here, there's a large amount of sediment that's stored in this reservoir over time, and much of this sediment was released when the dam failed. And so the National Park Service and my agency, the USGS, decided to investigate how this failure and the flood have impacted habitats on the Missouri National Recreational River. So for those of you who are not familiar with the National Recreational River, there are two main segments. There's a downstream segment, downstream of Lewis and Clark Lake, that's 59 miles. And then there's a 39-mile reach upstream of the lake that begins just downstream of the town of Niobrara, Nebraska, near the Standing Bear Bridge, for those that are familiar with the area. And it extends upstream to Fort Randall Dam, but it also includes the lower 20 miles of the Niobrara River, as well as the last 8 miles of a small tributary to the Niobrara called Verdigris Creek. So the Missouri National Recreational River has a wide variety of habitats, including channels, sandbars, backwaters, floodplains. And because of this, there's a large variety of species, birds, fish, mammals, reptiles, amphibians. And these include the threatened piping plover, the endangered interior least tern, and endangered pallid sturgeon. It's also highly valued for its exceptionally scenic areas. It's visited by tourists and outdoorsmen. It's used extensively for boating, fishing, hunting, bird watching. And if any of you have never been here, I definitely recommend it. It's a very unique ecosystem and just a lot of really interesting features to look at. So a little background of the dam that failed. So it's located about 40 miles upstream from the Missouri River confluence. And the Niobrara River itself drains a large area of the Sandhills ecoregion. And as you might guess by the name, it has a large amount of sand. So the Niobrara River has a large sediment load because of this. It was built in 1925 with initial capacity of about 13 million cubic meters. And with in about 25 years, that storage capacity was reduced to less than 1%. And so as you can imagine, this dam was not going to be operational or sustainable for very much longer. And so in 1950, sluicing gates were added to manage for the sediment. And since then, generally this stored sediment is released once in the spring and once in the fall. Now this is weather dependent, so some years it's only released once, or generally it's released at least in the fall, but there's, you know, if we have high water in the spring or things like that, they don't do it. So here's some photos of what the dam looked like before and after the flood. Up here, so the 4 gates just to the left of the powerhouse, those are the sluicing gates. And when they release the sediment, those are fully open. And then this is what the dam looked like after it failed. There's just extreme amount of pressure from the ice broke the gates open. And so, and actually the backside of the powerhouse, it broke open the concrete and brick. That's how much force was behind this thing. So here's an aerial view before and after. One thing I wanted to mention is, so there's, you know, historic sediments all throughout this reservoir. And when they flushed the sediment before the dam failed, yes, it released a large amount, but sometimes the channel would focus just in one area, and so it would leave a lot of the sediment undisturbed. So much of the sediment, it's possible that it's been there since the dam was created. So even though it clears out quite a bit of sediment, there's still a lot left. And so when the dam failed, it actually failed initially by where the levee was here on the south side. That's where the initial failure was, and there's a bridge right here that stayed, but the road to the south of the bridge was completely washed out in the channel. The channel is still today to that south side. The new bridge has been moved to incorporate where the channel is moved, and then the dam is up here in this photo. So what are we most concerned with because of this, as far as the Missouri National Recreational River goes? Well, we're wondering what might have happened to the various habitats, such as the channel habitats, sandbars, the backwaters. These are some very unique habitats to this area, and they're very important for the different species that use them. And we're also interested because the Spencer Dam was constructed prior to many banned pesticides, we're concerned about the possibility that some of these which are absorbed as sediments, the fine material sediment, these could have been transported downstream and deposited in backwaters or other depositional zones. And so we're curious to see if we find any of that. So for our scope, we are going to be resurveying some Army Corps of Engineers established cross sections. We'll be analyzing some satellite and aerial imagery, looking at sediment grain size for the sandbars, and then, as I just mentioned, looking at the possibility of contaminants. And then we'll be looking at other available data that other agencies collect to see if there's any of that we can use to supplement our analysis. It was a 3-year study. We just started the data collection this year, and we'll be doing more data collection next year with the final analysis and publication in 2022. So as far as the surveys goes, these are the sediment range lines that the Army Corps of Engineers has been surveying periodically since the 50s. And the purpose of those was because Lewis and Clark Lake is filling with sediment, and there's large aggregation near the town of Niobrara, and so they want to get a feel of how quickly that is happening. We're going to be focused on the range lines that are impacted by the Niobrara River, so we're not going to be doing very many that are upstream of the confluence, and we're going to be focusing mostly on the range lines that are in the Niobrara River itself. The last round was completed by Army Corps of Engineers in 2019, and once the flows went down in August. We've already completed most of our surveys for this year, and we'll be doing one more set next year. We'll be targeting areas because of lack of enough resources to do all the ones we wanted. We're going to be targeting areas of channels, sandbars, and backwaters, especially new sandbars and new backwaters. And that little plot there shows you how much the river has aggraded at the, this is at the confluence. And you can see that it's been a pretty substantial change. You know, even between 1983 and 2019, you've got 5 feet of channel bed rise. So as far as imagery goes, we're going to be looking at aerial photos from the USDA. There's some FEMA imagery because of the flood impacts, so we'll be able to look at that from 2019. And then the USGS Northern Prairie Wildlife Research Center has been working with Army Corps of Engineers, turning plover folks to classify habitat, and that's that bottom right photo you see. You know, they have algorithms that look at satellite data to determine sandbars and vegetated islands and that kind of thing. So we'll be using that to assist with this analysis. And basically we want to figure out, you know, how have these areas changed, and how are those changes persistent with these, you know, these next couple of years, or were they just a temporary normal? And then, so for sandbar sediment, we're going to be collecting grain size analysis samples. We'll be targeting sandbars based on tern and plover nesting data, as well as looking at either new sandbars from the flood or sandbars that expanded greatly because of the flood. And then the remaining sandbars will be just distributed longitudinally along the Niobrara and Missouri rivers. For contaminants, we are going to be sticking to the backwaters because that's where primarily all the fine material is deposited on the Niobrara and Missouri rivers in that area. And we'll be targeting either new or expanded backwaters. We're going to be analyzing these samples for organochlorine pesticides and PCBs, as well as arsenic, cadmium, zinc, and lead. So what do we hope to learn from this? Well, we hope to determine, you know, what extent these areas were impacted, specifically the habitats we're interested in. And did these changes persist during the duration of the study, or are they, you know, reverting back towards pre-flood conditions? And then have the sandbar grain size compositions changed, or do they vary depending on where you are in the system? Do you see more of an impact from Missouri River sediments in that area, or are they all pretty consistent? And then we'll use a lot of the tern and plover data to determine, did they change nesting patterns and that kind of thing. And then lastly, did we find any contaminants in any of these fine material samples that we're analyzing? All right, and with that, I'll take questions.
Great, thank you, Nathan. Again, if you have any questions, just put those in the Q&A. One question I had that I don't know if there is an answer for it, but does anyone know what the channel was like prior to the dam, and how it's changed, I guess, since the implementation of the dam, and then after the sediment release, and then now kind of back to a free-flowing river?
Well, as far as pre-dam data, there's, from what I know, I mean, obviously you're not gonna have aerial photos to look at.
Right, yeah, satellite.
So yeah, I don't know off the top of my head. That's a good question. but I can tell you just like I did a study prior to this looking at what occurs during times when they do the flushing, and it's
Okay.
amazing how quickly the river grades. Just it's completely down to bedrock before they start the flush, and then you just get these huge sand dunes that come in, and it goes up. I want to say it was over 10 feet just
Wow.
at the bridge downstream of the dam. So, and you see this, that you see the change in just the sediment or the sediment quantity of the river, even downstream, like 20 miles downstream, you'll see the concentrations increase, that kind of thing. So
Sure. Interesting. Here's a question related to the organochlorine residues. Any plans to measure that in downstream fish tissues or in other biota?
no, we're not doing that for this study.
Okay. Give another 10 seconds for anyone to put in a question. All right. Well, thanks so much, Nathan. Any plans to rebuild the dam? That's a good one.
Oh, no. So the funny part about that, well, I don't know if it's funny, but the interesting part about this is the dam was retired or set to be retired in the next couple of years. The Game and Parks Commission and some NRDs were working to get it retired. And they were still trying to determine if they were going to remove the dam or just leave the gates open, that kind of thing for fish passage. And so now it's kind of in flux as to like what to do about managing that area of the river. I mean, that it kind of took it out of their hands. And so, so it was planned to be retired anyways.
Gotcha. One more. Will this increase sedimentation in Lewis and Clark Lake?
Well, that's something that the Corps is very interested in, and so I think they're going to be looking at our data, and but that's outside of the scope of this particular study. But they will be using our data to kind of look at that.
Great. All right. Well, thanks again, Nathan.